You see, the target is unpredictable target. The outcome is unpredictable. If you work sincerely, if you use a reliable clustering algorithm, your output is efficient. Your output is fine, excellent output you will get. For example, I can tell you one thing. We have seen, I don't know how many people are familiar with spatio-temporal data. Because while discussing on data, you have the word of spatial data. What is spatial data? Location, spatial data. Now I am staying here. This is my spatial data. Longitude, latitude, northeast, like that we used to give. What is spatio-temporal? For example, you see, from this place to this place I have navigated like this. What is the meaning of navigation? I walked from that place to this place. Means the point, first point I am here. After 2 minutes I am here. Like this I am moving. What is that? That data is called spatio-temporal data. What is temporal? Temporal is nothing but the timestamp. Temporal is nothing but timestamp. For example, you see medical, doctor diagnosis. Doctor is there. What he will do? You please see the case study. For example, one cancer patient joined in a hospital. Cancer patient. What the doctor will do first? He will perform some sort of testing. What is his hemoglobin percentage, urine test, other test, BP, how much, sugar is how much, like that. They will collect some characteristics of the person, properties of the person. He will see, he will observe. Yes, maybe he is having high BP. His hemoglobin percentage is less. These cells, white cells are more. Like this, he will observe. Then what he will do? He will give some sort of medicine. Continuously he will give medicine for 3 days or 4 days. Later again he will perform the test. Right? To see the progress. What is the response from the patient for this medicine? Okay? These are called temporal events. First day, day 1, this is his percentage. Day 2, these are the properties. Day 3, like this, he will see. That is for one patient. If I get data from the complete hospital, maybe 10 patients I will get. If I get from the entire Kakinada district, I may get 100. If I get from the entire state, I may get 1000 or more than that. That data set is very, very important. That data set. We cannot get this medical processing data, because that is a sensitive data. No one will show interest to give. If some cancer patient is there, he will not allow to reveal his name, right or not? That's why privacy also enter into it. You may heard of privacy preserving in data mining. What is privacy? Security. Being a medical patient, you don't want to reveal his credentials, his name and all. That's why while giving the medical data, doctors will remove the patient name and his address. Then only he will give the data. Some anonymous person's data. We need to understand, we need to study that data. For what purpose? For what purpose we need to analyze? Nowadays, see, e-medicine. What is e-medicine? E-medicine. We can get medical prescriptions or medical advice without contacting the doctor. Or even without meeting the doctor also you can take. If you have such type of e-solution, if a cancer patient comes, after performing testing, he can give input, my blood cells are this much, my white cells are this much, this is BP, this is sugar content, like whatever the property, he will give some questionnaire, he will answer the questionnaire. Because he analyzed the entire data, 1000 patients data, he understands what medicine is suitable for this person, automatically treatment can be given. Either you can meet or without meeting the doctor, you will get the treatment. This is the advantage of data mining. This is the advantage of data mining. We need to utilize the support of IT. Information technology. Information technology has grown like that. It should meet common people. It should support common people to provide these type of, not only for this agriculture. Environmental prediction. Today morning we discussed. Today morning I discussed with VC Veera and even our principal joined in the discussion, Professor Ramchandran. He told about how we are able to utilize weather prediction. He told because in car is there in Hyderabad. In Delhi, NMER is there, National Mitigation Meteorological Department. They are maintaining the servers. They are getting the data, observing the data, simulating the data. They are simulating and getting the prediction, forecasting. That forecasting helps the agricultural farmers, and at the same time, see, somewhat hudhud impact is predicted, right? Previously, somewhat hudhud impact was predicted. They gave guidance, don't stay near the beach road, like that. They used to give that type of suggestion. These all are possible because of the data mining. El Nino, you know, season movement, El Nino. Even not only that, while describing the data itself, I mentioned UCI, California University, UCI, California data set is there. Lot of data sets are available, real-time data sets are available. One more example for this one, spatio-temporal data. What the London people did is, they purchased some sensors, 50 sensors, and added the sensors to the ears of the deer. They added the sensors and left the deers in the forest to know the movement of deers, how they are moving. Whenever I am saying that my sensor is there, my tower will collect using GPS. What is the location? Means by visualizing that thing, I can say that all the deers are moving in this direction or in this direction, based on the movement. For what purpose it will support? Maybe which climate is supporting for the deers. Not only for this, for whatever you want, you can do that. You can analyze. And at the same time, one more thing, Paris. You know, everyone knows about Paris. There is one museum, Louvre Museum is there. Louvre Museum, where original portrait of this beautiful lady, Mona Lisa, yes. That original portrait is kept in the 5th floor of Louvre Museum. 5th floor of Louvre Museum. I visited in 2008, I went there, I got the opportunity to see the portrait and all. Whenever we went there, they used to give one GPS based device to know it will guide. Not only that thing, what points, they have not included all the entire museum's data. They developed one virtual museum. You know, virtual museum. They developed one virtual museum and kept in the web open. If you want to see Louvre Museum before going there, you can navigate the virtual museum by sitting in front of computer. On what areas you are showing interest, they captured the data. Okay? On what areas this customer is showing interest, this user is showing interest. They captured those ideas and developed the museum like that. You see, getting feedback is a difficult process. But whereas virtual means you are no need to spend that amount to visit the museum. You know, before going there itself, you will get an idea of Louvre Museum. Once you can go there, after going there, you can concentrate wherever you want to concentrate. Several advantages are there. But what in clustering, in the context of clustering, they will give groups. They can divide the groups. Yes, these people, these are the young generation, young people are navigating like this. And at the same time, one very good example for web analytics, website analytics. I mentioned web leeches. What is web leech? What is web leech? You see, we have JNTUK.edu.in server, right? We have JNTUK.edu.in server. Almost every day, I used to get 10,000 hits. What is the meaning of hit? 10,000 people are visiting the JNTU Kakinada server. What is our home page? First one, jntuk.edu.in, right? jntuk.edu.in is our home page. You can type jntuk.edu.in home page. After visiting home page, where the people are going? After visiting home page, where the people are going? People are visiting next. 70% of the people are visiting result section. After visiting the result section, where they are going? Say, again home page, result section, again home page. After visiting home, again they are coming to notification section. After visiting notification, again they are going to home page. After this, they are visiting some circulars. Again, they are going to home page. Now tell me, because this is not for our JNTU Kakinada website. There is one data set called MSNBC. Use California University UCA data set is there. MSNBC website is there. Almost we will find 1 million records. 1 million records of user navigation. When I visualized the data, I got this type of picture. That is nothing but a spatial temporal. That is nothing but in our language, in our physics language, if I throw a stone, it will follow the path, its own path. That is nothing but the trajectory. Right? That is one type of trajectory. I have visualized that thing. After analyzing the 1 million records, I observed that maximum records are visualizing like that. Why they followed that path? Anyone can tell? Because more students are visiting our website. That's why after visiting homepage, people are visiting the result section. Okay. After visiting result section, why people are going to homepage again? Yes, come out. That's an important concept we need. Okay, like that you can mind. Suppose if the student fails in that subject, he wants to go to circular where the supplementary examination notification will come. Okay, that's a different case. Very few people, only 10% or 15% people will fail. Now I am telling you, lot of all 90% of users are visiting like this only. Then what's your answer? What is the advantage? Clustering what? Producing. It is giving. After visiting home page, maximum people are going to visit result section. By knowing this thing, my system administrator will put the result section in the main memory of server, so that fastly it can give response. Latency time can be reduced. That is the one point. Second point, after visiting results, why user went to home? Again, after visiting home, why he came to notification? Okay. After visiting notification, again user went to home. Again he visited circular. Why? After analyzing the MSNBC data, I observed one thing. Olden days, they have not provided the links for subsections in each and every page. Okay. If I provided the link to access result section in home page only, from result to notification, it is not possible for me to navigate. That's why I came back to home section and navigated to notification section. From notification to circular, there is no hyperlink to access. That's why I am forced to come back home and access it. Yeah, this is called the visualization. That is the advantage of visualization. These type of cycles were happen in the data set. These type of cycles were happen in the data set. These are the test cases. Several test cases are there. Several real-time applications are there. Those help the analyst to understand correctly. It helps, right? To analyze. Later they modify the, now you will find, you can use MSNB set, you will find different picture. Okay? After taking lot of, even if you observe UCI California data set, you will find same data set there. This is one type of web application, trajectory clustering, spatio-temporal data, spatial data, okay? Like several things. Coming to these things, we have several clustering algorithms. Past classes we discussed about k-means clustering. Yes, you know advantage of k-means, strength and weaknesses of k-means. Next we visited hierarchical clustering. The hierarchical is always advisable. Why? Because if the data set size is small, it's advisable to go for hierarchical. Okay? If the data set is more, it's difficult. It will take a lot of time to build the hierarchical tree. After building the tree, it's very easy. How many number of clusters you want, you can get very easily. But initially building is complex, difficult. Okay? That's the disadvantage of hierarchical clustering. We have seen complexity. What is the time complexity? Yes, yesterday while building the hierarchical tree, how many times we prepared the dissimilarity matrix? If you observe, For n element, almost n minus 1 times or n minus 1, 2 times, n minus 1 times, we need to build the dissimilarity matrix. If it is 1 million records, how many times you need to build the dissimilarity matrix? Is it possible? It will take lot of time. Not only main memory, okay, you can use secondary storage algorithms. Now big data analytics is supporting a lot. Okay, use distributed memory to load the data and at the same time to process the data. Yes, order of n square space, since it uses the proximity matrix. Proximity matrix, even in case of proximity matrix also you can reduce, because you please try to recollect the previous proximity matrix. N by n matrix we have drawn, right? N by n. Almost upper diagonal matrix and lower diagonal matrix, both are the mirror image, right? If you are able to construct only lower diagonal matrix, that's sufficient. By using that thing, you can save memory time. Whatever it may be, computational complexity, same. You need to perform number of computations. That's why n is number of points. As n is number of points, order of n square is the space complexity. What about time complexity? There are n steps, and at each step the size is n square. Proximity matrix size n by n is n square. Okay, must be updated and searched. Each and every time you need to update and you need to search. Why you need to search? Yes. What is the value? Is smallest value. For that purpose you need to search the matrix or not. That's why n elements n. Order of n square into n. Order of n cube. That is the time complexity. Even you can reduce, complexity can be reduced to order of n square log n time for some approaches. Yesterday I mentioned a Watts method is there. Watts method. Like this type of computation, you can reduce the lower diagonal matrix. You can search, instead of searching n by n matrix, you can searching lower triangular matrix. By searching only lower triangular matrix, you can reduce the number of computations to logarithmic n, from n to logarithmic n. That's why we achieved this order of n square into log n for time complexity. Next. Fastly we will navigate. Yeah, we have seen, I think I have no need to explain about this thing. Time complexity, logarithmic to number of objects in case of k-mean, whereas hierarchical, order of n square. Why? Because the proximity matrix and searching and all there. Shape of clusters, yes, k-mean support for creating globular shape clusters, whereas some variety of hierarchical clustering supports for creating elliptical shape. Okay, and this one arbitrary shaped clusters also, non-spherical. Then probably k-means is not a good choice if you want to build. Next slide please. Repeatability, yes, we know k-means we need to repeat based on the number of iterations. In case of hierarchical, you are no need to repeat, but the disadvantage is initial building the tree itself is a complex thing. As the number of objects are increasing, tree becomes very big, very huge. Of course, k-means is prior knowledge is required, whereas hierarchical, you are no need to give any k. Next slide please. Bisecting k-means we have seen. Bisecting k-means is nothing but the combination of k-means and hierarchical clustering. What we need to do in this bisecting k-means, you need to identify which cluster you want to split. That is the complexity. After identification, you can split the cluster as per k-means criteria. Number of times you need to iteration. Number of times you need to repeat the iterations. Yes, that's why it is somewhat modified version of bisecting k-means. Yes, the critical part is which cluster to choose splitting. Yes, you know, I advise you to select several parameters are there based on the size, proximity. Whichever is having highest proximity, you select the cluster and divide, so that you can get less sum of squared error. Okay, to get quality clustered. Next slide please. Yeah, this one. This is our role is density based clustering method. The third one, three clustering techniques are there: partition based, hierarchical based, and density based. These are the three things: partition based, hierarchical based, and density based. Previous classes we have completed the k-means, you see, partition based and hierarchical. This one is the density based. The meaning itself represents density based clustering. Based on the density, we are forming the clusters. Wherever the dense regions are there, there will be a cluster. If there is no dense, there will not be any cluster. If any continuation is there, the cluster also will form like that. If continuity is there, means there are some meanings are there. Directly reachable, not reachable, like some definitions we need to learn. Okay, please see, clustering based on density, local cluster criterion, such as density connected points. Yes, connection. Suppose you see, these three are having dense. Why? Because connection is there. Okay. Next connection in this direction is there. This direction is somewhat more radius, distance is more. Like this. Major features are discover clusters of arbitrary shape. This is the first major strength of density based clustering. Discover the clusters of arbitrary shape. Handle noise. Noise can be handled very efficiently. One scan, single scan is sufficient to build the cluster. Need density parameter. What is this density parameter? For example, you see, class. What is the minimum number of strings? If I want to handle, I need to. Okay, need density parameters. What are the density parameters? What parameters? When can you say this cluster is dense? Again, you need to have domain knowledge. For Indian climate, 50 is the UG student strength. That is minimum. Whereas if you go and see in Sweden, you may get 10 students. Because that strength is, for that university, that strength is very big. Okay, for our 50 is minimum. Whereas if you go to some other college, they will get KL University, 18 sections are there, computer science. Maybe. They are having that much demand. When they can say that's a density, yes, my cluster is full, my class is full, based on that strength. Okay? Need density parameters. Several interesting studies. Yes, you need to understand this thing. DBSCAN, Esther et al. DBSCAN, density-based scanning technique. Each and every word, each and every character is having expansion. Density-based spatio-temporal spatial clustering analysis. Some definition is there, expansion is there. Let us see. What is this KDD? I don't want to give importance for the expansion. I want to give importance for this one. Huh? Knowledge discovery from databases, KDD. What is that KDD 96? Tell me. KDD, knowledge discovery from databases. That's an international conference organized in 96. This DBSCAN algorithm is proposed by Esther et al. Esther et al. Are the authors of DBSCAN, proposed in KDD 96. That is the meaning of that representation. Just I want to tell you that. Okay? Otherwise, technically, we are technical students. We studied in university college. We don't know what is the meaning of it. See, next one is DENQ, density clustering, clue, another technique, which is introduced by these two authors in 98 and 2006 also they produced. Optics, Anchor et al. Sigmod, SIGM board, ACM Sigmod 99. Click, Agarwal et al. Yes, you see this one Agrawal. He is very popular author in data mining. Like Khan and Kambar is there, Vipin Kumar is there, he is another author. Agrawal, Charusi Agrawal. Okay. These are the several interesting studies on density-based clustering methods.
They are kind enough to accept.
DBSCAN is a density-based algorithm. Density is nothing but the number of points within a specified radius. That here you need to remember some words. EPS is the minimum number of points. Minimum number of points, minimum number of points within a specified radius. Number of points is N or M symbol is there. What is the radius? EPS is the radius. Proximity, EPS is the proximity. If minimum number of students are there, then only I will concentrate on this. If only one student is there, I may not show interest. Because you see the proximity. At least if two students sit in the tree, I can concentrate. Okay, that is the minimum number of points. A point is equal. A point. Suppose you see several points are there. Several points. For example, you see these are the points. These are the points. A point can be core point, border point, outlier. A point can be core point, border point, or an outlier. What is core point? A point contains more than density points. I told you now, density is nothing but the minimum number of points it should have. A core point, this is a core point. Why I am saying this is a core point? Within EPS region radius, it is having more number of points. What is the number of points here? Say, my number of points are 4. How many number of points are having here? More than 4. That's why this is core point. If I say, what point is this? Or what point is this? Border point. Why I am saying border point? Within the EPS, only 4 are available. That way it has not become the outlier. What about this thing? EPS, only 1 point is available. That way noise or outlier. Okay, these are the definitions of point. In density based clustering, you need to remember 5 points. One is EPS. EPS is nothing but the radius. Okay, n equal to number of points. How many number of points? You need to fix based on your domain knowledge. Third one is point type. Core point, border point, outlier. Okay, these things. Okay. Number of any number. For example, you see here I am having. If this core point is directly reachable, then again it will become one more. Then you can combine these two as single cluster. See, previously it's a circular shape. Whenever I combine two circles, it becomes non-globular shape. Okay, that is the advantage of density-based cluster. We'll see. We'll go through that. Okay. Yeah. Core point. A point is a core point if it has more than specified number of points. That is nothing but the minimum points within EPS. I mentioned the EPS is nothing but the within the proximity. You can use the word site. These are points that are at the interior of a cluster. Yes. Core points are always interior, center to the cluster. A border point has fewer than minimum points. I told you, no? Fewer than minimum points within EPS. But it is in the neighborhood of a core point, not neighborhood of a core. A noise point. What is a noise point? Is any point that is not a core point or a border point. That point is there we have seen. That is not core point and not a border point. Or I can say noise or outlier or something. Yeah, you please see this diagram. You need to remember this diagram very easily. This is regarding the dissimilarity. This is the noise point. Why? Because how many number of points? Minimum points? 4. You see, core point is this. How many? More than 4. Border point. You see this thing? This is, if I draw EPS circle, maximum 4 points are coming. This one, 1, 2, 3, 4. Only 4 points. That's why this point becomes the border point. Okay. Next, what is this noise point? Why it became noise? If I draw circle from this place, only 3 points are there, not 4. Whenever it is having its density is 3. That's why this is not a cluster. That these, not only this point, even these 2 points also fall under noise point. Noise point. Okay? Minimum points is 4. Hidden Markovian model, HMM, have you gone through that? Hidden Markovian model. That principle, that's also there. That principle you need to see. Right? Next one. Very easily you can draw the diagram, right? DBSCAN. Density based clustering locates regions of high density that are separated from one another by regions of low density. How can you separate? That's the important concept. Density equal to number of points within a specified radius. Yes. Core points. These are points. Border point. Next one. A noise point is any point that is not a core point or a border point. Any 2 core points are close enough. See, any 2 core points are close enough within a distance of EPS of one another are put in the same cluster. That you need to understand. That's why cluster size reclustering can happen. I am not increasing the number of points. I am saying only 4 points. Any 2 core points are close enough, that is within an EPS distance, are put in the same cluster. Any border point that is close enough to a core point is put in the same cluster as the core point. Any border point that is close enough to a core point is put in the same cluster as the core point. Noise points are discarded. That's why noise can be eliminated using DBSCAN clustering technique. It is not sensitive to noise, whereas K-means is highly sensitive to noise. Next. Yeah. This is another diagram. Several approaches they use. This is outlier. This is the border point. These are the concepts. Epsilon. Some textbook used to say epsilon. What is this epsilon neighborhood? That is nothing but EPS only. Objects within a radius of epsilon from an object. Epsilon neighborhood. Core object. Neighborhood of an object contains at least minimum number of points. This is the another way of representing the diagram. We need to see whether directly reachable or not. Next. Concept. This concept is important. The definitions, 4 definitions we need to find. Reachability. Directly density reachable. What is directly density reachable? An object Q is directly density reachable from object P. From object P. If Q is within epsilon neighborhood of P and Q is a P is a core object. Means P should be a core object. When Q point becomes directly reachable, it should be within an epsilon reachable, and at the same time border point or core point. Okay? Minimum number of points it should contain. Directly, yes. See, difference is very small. Directly density reachable, this is only density reachable. Density reachable. An object P is density reachable from Q with respect to minimum points if there is a chain of objects PL to PN, that the period symbol is there, PL to N, LMN, like that. Okay, continuation, PL to N, where PL equal to Q, PN equal to P, such that PI plus 1, see, next point of PI plus 1 is directly reachable from PI with respect to epsilon and minimum points for all points. L is less than or equal to I, which is less than or equal to N. Okay, this is density reachable. Q is density reachable from P. When P is not density reachable from Q. Is it question? Is it correct? See, Q is density reachable from P, whereas P is not density reachable from Q. Transitive closure of direct density reachability is asymmetric. Asymmetric means it won't follow the principle of symmetry. You know, while defining the measure and metric, there are 2 words, measure and metric. When a formula Euclidean distance becomes the measure, it follows the 3 principles. Principle of symmetry, A to B equal to B to A. Transitivity, any 2 objects distance is greater than the third object distance. Next one is object. If A distance from A to B equal to 0, then A and B becomes to both objects. Symmetry, transitivity and triangular relation. Those 3 you need to follow. Whereas this one is asymmetric. That's not a mandatory thing. Next one. Density connectivity. Directly density reachable, density connectivity. Seems to be some ambiguous will be there, you need to go through that. Right? Object B is density connected to object Q with respect to epsilon and minimum points if there is an object O such that both P and Q are directly reachable from O. See, R with respect to epsilon and minimum points. P and Q are density connected to each other by R. If R is there, then these 2 are connectly reachable. Density connectivity is symmetric here. In previous case, asymmetric. Okay, next. Because previous one is the border point, whereas this one, these 2 are the core points. That you need to understand. Concepts, cluster and noise. Cluster, a cluster C in a set of objects D with respect to epsilon and minimum points is a non-empty subset of D satisfying. When can we say it's a non-empty cluster? Maximality for all P comma Q if P is proper belongs to C and if Q is density reachable from P with respect to epsilon and minimum points, then also Q belongs to C. Okay, connectivity. These are the definitions you need to remember. If you want to implement density based clustering technique, you need to know all the things. In programming or Java or something else, you need to implement these constraints. You know, very easily you can understand core point, border point and noise point. If there are two cover points and those are directly reachable, then you can combine that thing as a cluster. That is nothing but this stuff. Okay? Maximality, connectivity, noise, objects which are not directly density reachable from at least one core point. This is very important. From at least any one core object, if the point is not reachable, then that point is treated as the noise. Otherwise it will become border point. Next, indirectly density reachable. What is indirectly density reachable? Density connected. See, indirectly density reachable. I may not reach Q directly, but through point R I can reach. That is also possible. This Q is also a core point. Okay? Even if the density is connected, yes, like this, then it will become the shape of the cluster is like this only. Next, that's why merge option is there, merging criteria is there. The algorithm is very simple. And what you need to observe is the words, the sentences are only 4 sentences. In K means hierarchical, DBSCAN. Unless and until you implement manually, you can't find the difference. See, select A point P, no problem. Retrieve all points density reachable from P with respect to epsilon and minimum point. Very simple. If P is a core point, a cluster is formed. If P is a border point, no points are density reachable from P and the DBSCAN visit the next point of the database. Continue the process until all of the points have been processed. That's all. Very simple. Writing one paragraph. Select a point P, retrieve all points density reachable from P. Even you can select one point. Even for this also you need to compute dissimilarity matrix or not? Dissimilarity matrix? Yes. Don't sleep, okay? Dissimilarity matrix is required or not? Yes. That's why even if you see R16 batch syllabus, I have included measures of similarity, dissimilarity and this syllabus. Without knowing similarity and dissimilarity, how can you? Okay? Yes. Retrieve all points density reachable from P with respect to epsilon and minimum point. When it will become, if it is, I can find one point within the EPS. From that point I need to check how many number of points are within EPS. If at least minimum number of points, then I consider as a core point and combine. If it is minimum number of points are not there, I can treat it as a border point. Because why I can treat it as a border point? This is reachable from core point. If no points are there, I can stop. I will select next point from the database. Okay, this entire thing will fall one cluster. Next point, whenever I am saying, that becomes the another. Building up, starting to build another point. That you need to understand. Select a point P. Retrieve all points density reachable from P with respect to epsilon and minimum points. If P is a core point, then only cluster formed. That you need to understand. If P is a border point, no points are density reachable from P and the DBSCAN visit the next point of the database. Means when it is a border point, it is not having more points, no. That's why we break the loop and go to the next point. Continue the process until all of the points have been processed. Result is independent of the order of processing the points. Yes, this is another point. In case of K means, first I have taken one point. After putting this thing into any one of the cluster, then I am taking the second point. Whenever I am inserting one point in the cluster, I am computing the average. Right? Means Whenever the sequence is followed, the point, we don't know where this point shows impact on what cluster, I don't know. Whereas here, I have selected one point, all points I counted. If it is not reachable, then only I am going. Even if you take from reverse, vice versa also, whenever you will get the break, then it will form the new cluster. Right? You are not changing the average value. In case of k-means, we are modifying the average. Here average is not changing because spatial location we are not changing. We never use the word of average. We never use the word of mean in DBSCAN. That you need to catch. Next one. As an example, yes, you can see minimum number of points is 4 min. From this point, 4 points are there. Then another cluster. From this point, it will verify from which point onwards is cluster. Yes, this point, that is the border point. That's why it has selected that point. Again, it formed the cluster. These two clusters can be combined. Okay. Next. Determining EPS. This is the next case. In case of k-means, we know how to select k value, how to select initial centroid. Whereas here, how to select epsilon, how to select minimum number of points. I told you, you need to have the domain knowledge. How many number of points? If it is a dense, 4 points minimum, 10 points you can take. If it is not that much dense, even 3 points are also maximum. Distance from a point to its nearest neighbor is equal to or greater than k distance. For points that belonging to some clusters, the value of k distance will be small if k is not larger than the cluster size, proximity. What is the cluster size? If it is less than that, it can form. For points that are not in a cluster, such as noise points, the k distance will be relatively large. If you don't want to consider as noise, even though I am having 10 points, 10 are important, I need to reduce my size, proximity size. Okay, I need to increase the radius so that all points will fall within the cluster. Compute k distance for all points for some k. Sort them in increasing order and plot sorted values. See, this is important. Compute k distance for all points for some k. K points means k distance means k number of points. For example, see, I stayed here. What is k distance? Means k number of points is 3 points. This is less than k, 1 point. This is another k. Yeah, that is third point. My k distance is from me longest point, so that if I draw a circle, I can reach the 3 people within that circle. That is my k distance. Okay. K distance means k is number of points. How many number of points you want to consider? Minimum number of points. Say 2. If I told 2, my k distance is, this is 1, this is 2. Yes, I got 2 points. That's why this distance itself is the k distance. Means it directly depends on the minimum number of points. Okay, sort them. From each and every point I need to calculate like this. I need to sort. Whichever is having smallest, I will consider. Yeah, a sharp change at the value of k means, if you see the diagram, wherever the boot changes, means wherever the boot changes, this portion, this point we need to consider as the minimum number of points and k. Wherever the direction changes, boot changes, booting point we will call a sharp change at the value of k distance that corresponds to suitable value of EPS and the value of k as minimum points. You need to highlight this word, a sharp change at the value of k. Means a sharp rise. Means k rising means lot of distance you need to travel. I don't want to travel that much. That's why that point, that is the, what we need to say, optimal point. Optimal point to select k, minimum number of points. Next one. Next. DBSCAN. A sharp change at the value of k distance that corresponds to a suitable value of EPS and the value of k as minimum points in the form of algorithm. Points for which k distance is less than EPS will be labeled as 4 points while other points will be labeled as nice or border points. If k is too large, small clusters of size less than k are likely to be labeled as noise. If k is too small, even a small number of closely spaced that are noise or outliers will be incorrectly labeled as k. Number of points is small, then number of points are more, again opposite. Next. To eliminate noise points, this is the algorithm. Perform clustering on remaining points. Yes, you can go through that. Whatever points we discussed previously, those points are mentioned in the form of algorithm. Next. Yeah, this is possible. In previous class, I think I have shown this diagram. Have I shown? No. Yes, you see, this is original points. Original points. If I consider three types of points are there. What are the core points? Color coded way. Green color points are called the core points. Blue color points are treated as the border points. Red color points are treated as the noise points. Color coding you should understand because already you completed Java programming. Right? AWT is or not? Abstract window toolkit. Swing is an application, you know. Whenever I want to visualize graphically, I need to use swing. Olden days we used to advise them to go for applet. You know the disadvantage of applet and AWT. Compare and contrast. You can write, na? That's why now we are advising them to go for swing. Paint method is there. Very good. Paint always, right? It refreshes. These are the green points are core points, blue points are border points, and red points are the nice points. That is the color coded. Next one. We can complete very fast. And when DBSCAN works well, this type of clusters will form. When DBSCAN works well, resistance to noise, yes, can handle clusters of different shapes and sizes. See, next. When DBSCAN does not work well, these are the original points, same minimum points are EPS 9.75 distance. This type of clusters will form. But we can't say which cluster related to which. Varying densities and at the same time the possibility is high dimensional data. Always you see, whenever it is having more dimensions, when it is having more number of dimensions, dimensionality problem will come. Dimensionality, as the dimensionality is increases, computational complexity for building similarity matrix. Whenever the construction of time required to construct dissimilarity matrix is increases, overall complexity increases. That you need to understand. That's why we used to say curse of dimensionality. What is curse of dimensionality? Itself is curse of dimensionality. That's why what we are using to reduce the dimensionality? Principal component analysis. Indara, have you heard that word? No, not in data communication. In data mining itself, we have the, during pre-processing, we will study principal component analysis. You go through that, okay? Principal component analysis is very, very important. For example, you see, I am having a data set with 10 dimensions. My algorithm works for only 4 dimensions. What 4 you need to consider? In case student database, it is very possible for you to identify which is task relevant data, which is task irrelevant data. So registration number. My task is employability. Registration will not play a crucial role getting placement. Name of the candidate will not play getting the placement, whereas gender can play. Some companies, they want to take only female. Some companies, they want to take only male member. Some companies, they don't want to give any gender priority. Anyone is. The type of is there or not? You need to think. Okay. In that case, you can't say that is task irrelevant data based on the goal. That's why PCA, Principal Component Analysis, is one best tool to give weightage for each attribute. For example, 10 dimensions are there. It will give eigenvalues and eigenvectors. Eigenvalues. It gives weightage for each and every dimension. Results, category, play crucial role in placement. Category. First class with distinction. That category plays a crucial role. That's why it can give 50% weightage for the category, 15% weightage for mathematics marks, 25% weightage for programming subjects, 5% is for one, 5% is for one. My algorithm works for only two-dimensional data. Then I will select 50% weightage and 25% weightage. I can ignore remaining dimensions. Means how to assign weightage using that PCA. That PCA tool helps you a lot to obtain the dimension, to analyze the data set. I used to tell domain knowledge. What is domain knowledge? Analysis on the data. Data set analysis. How can you get? Using statistical methods. Mean, median, mode, standard deviation and all. These are only those tools are there. Okay, using that thing you can analyze the data, you can give weightage for dimensions. High dimensional data, these type of problems can happen. Okay, next. Determining EPS. I told you this bootcut will come. Okay, you need to sort distances and to draw the graph. Wherever you will get abnormal change, that point will be considered as the wherever you will get abnormal change, that point will be considered as the K, and the number of points is minimum number of points. Okay, next. Complexity, last. Time complexity is order of n square, because single scan is sufficient. Like K means I am no need to perform number of iterations, right or not? Single scan is sufficient. And at the same time, it is not at all depending value K. It is not at all depending number of clusters, right? And at the same time, dissimilarity matrix only once if you construct that sufficient. You are no need to reconstruct. That's why DBSCAN is faster than AB and time complexity order of n square. For each point, it has to be determined. If it is a core point, it can be reduced to order of n log n in lower dimensional spaces by using efficient data structure. Means maximum complexity is this much order of n square. If you use some advanced technique, you can reduce it to order of but cannot be order of n cube, right? And space complexity is only number of points, order of n. Okay. Next, summary. Good. Can detect arbitrary shapes, not very sensitive to noise, supports outlier detection, complexity is kind of okay. Beside K means the second most used clustering algorithm. Means if you observe the literature, typical nucleotide clustering, K means clustering, number of hits, within 0.000 second, you will find 30,000 or 40,000 hits. If you type hierarchical, you may get lesser. If you get DBSCAN, moderate value. Like by that thing only they will find this one. Beside K means the second most used clustering algorithm. Bad, does not work well in high dimensional data set. Always. Why? Because parameter selection is tricky. Has problem of identifying clusters of varying density. Which density I need to consider based on the density. Suppose see how you need to see. Parameters are 6. Intermediate. Parameters are 6. What are the subjects? English, Maths, Physics, Chemistry. What are the other two? Okay. 2 other subjects. If I see Maths, density is very close. In case of Maths MPC students, marks variation from one student to other student is very minimal. That's why density is high density. If I see with respect to social, maybe long variation I may get it. Physics and chemistry, some more. English, right. Means you see whether the density is based on the dimension or not. Yes. Mathematics means who will join mathematics, MPC group. Whoever having interest in maths, they will study. That's why maximum marks is 149 to 139. Only 10 marks variation. English, they are forced to study. That's why some people will get pass marks. What is intelligence people get 90. The variation. That variation is nothing but the dimension, density. That density is not, depends on the attribute. Dimension. What attribute? Means on what dimension you construct the discipline. That okay. Core point అనేది ఎలా చెప్తున్నాం based on the density only, no. On what density? That is complex thing in density based one. That's one. has problem of identifying clusters of varying densities. Density estimation is kind of simplistic. Does not create a real density function, but rather a graph of density connected points. Again, you need to connect density. Moderate density you want, because mass all are closer, I can't separate them. English, lot, I can't. Say physics, chemistry, where I am thing, I will select like that. See, next one. This is the last slide, I think. Okay. I want to spend only 2 minutes on this cluster validity, because this is, even though it is not in your syllabus, why I am telling about cluster validity is, unless and until you have validity function, we can't say which clustering is good. Cluster validity, previously I used to tell inter-cluster distance, intra-cluster distance. Same thing we are using here. Inter-cluster distance, intra-cluster distance. I want to have less inter-cluster distance, more intra-cluster distance. That's our good cluster. That's our cluster validity. Means again, how? Whether it is implicit, it depends on the characteristics, or explicit. You are seeing from outsider. Another clustering technique came, multi-view similarity. Instead of using single view, only single dimension, I am seeing from your respect point of view how much distance I am. From his point of view how much. From his point of view how much. Like this I will calculate. I will put whichever is having lower, I am putting in that. Like this, multi-view similarity. Okay? For supervised classification, we have a variety of measures to evaluate how good a model is. Tell me, supervised classification is over now? What are the validation techniques used for classification? What are the validation techniques used for classification? Have you heard about bootstrapping? Bootstrapping? No? Yes. Next. Any other? Bootstrapping, Z-fold cross validation, V-fold cross validation. You need to browse the textbook classification. Everything, clustering, I mentioned now inter-cluster distance, intra-cluster distance. How can you say classification is correct? How classification is implemented? We will take the data set, divide the data set into two parts, test set and training set. This training set is to perform the model. After building the model, we need to validate with the test set. Now tell me, after that what? How can you measure the performance of this model? How many hits are correct? 100 data sets are there, 100 instances are there. Out of 100 instances, I have taken 40% is used for, 60% used for training the model, remaining 40 I used for testing the model. After building the model, I have selected out of 40, first point, I removed the class label. Using this model, what it predicts? Yes, credit card can be given, yes or no, yes or no. Like remaining 40, I predicted value. Predicted value and actual value I compared. Right? Is it possible or not? I compared. How many is true? I will select. Say 30 is true. Out of 40 predictions, 30 predictions are correct. That's why my model is 75% efficient. Support count is that is okay. This one, have you understood this thing or not? Yes, this is the way we will validate the classification model. Accuracy, how much accurate? 75% accurate. Precision, how many times I need to recall? Yeah, those are the things. For cluster analysis, the analogous question is how to evaluate the goodness of the resulting cluster using intercluster and intracluster, or SSE, simply sum of squared error. Next, but clusters are in the eye of the beholder. Okay, then why do we want to evaluate them? Because blindly the clusters are formed. I won't bother whether the correct clusters are formed and wrong clusters are formed. To avoid finding patterns in noise, to compare clustering algorithms, to compare two sets of clusters, to compare two clusters. But whenever you want to compare, you need to evaluate. Okay? Whenever you want to compare, you need to evaluate. Because in clustering classification, there is target class and such type of things. In clustering, there is no. But why we are doing this? To achieve this. Next. clusters found in random data. See, random points are there. K-means is clustered like this with the 3 clusters. DBSCAN is clustered like this. Complete link clustered like this. Which one is correct? We can't tell. Even by seeing visualization visually, can you justify? No. Next slide. Different aspect of cluster validation. There are internal validation and external validation. Determining the cluster tendency of S data, that is distinguishing whether non-random structure actually exists in the data. Means, why I am previous visualization, you see, why I told it is not possible for us to visually justify. If it is only 2-dimensional data, you can. If it is 10-dimensional data, how many dimensions they use it to visualize, we don't know. That's why we can't judge by seeing. Comparing the result of a cluster analysis to extremely known result, externally known result. Example, to externally given class label, hybrid cluster. Evaluating how well the results of a cluster analysis fit the data without reference to external information other than dimensions. Use only the data. Comparing the results of 2 different sets of clusters analyzes to determine which is better. Determining the correct number of clusters. How to determine the correct number of clusters? For 2, 3, 4, we can further distinguish whether we want to evaluate the entire clustering or just individual clusters. This is also an important case. Whether you want to see complete solution or you want to see only particular cluster. By discussing that thing only, we can suggest the measure. Next. Measures of clusters. See, these are the measures. You need to remember these things. External index, internal index and a relative index. External index is used to measure the extent to which cluster labels match externally supplied class labels. Externally spread. Whenever I say by seeing the property, dimensions and all, whenever I told, he used to think, yeah, he got 80%, then he belongs to computer science. Say, he got only 40%, maybe he belongs to electrical department. You see, externally supplied, whether I can get that percentage. Just I am funning with you, okay? You see like that type of clustering. External knowledge we are using. These are not the properties of the candidate. External knowledge I am using. My internal index, use it to measure the goodness of a cluster structure without respect to external information. That is nothing but the sum of squared error. Sum of squared error is nothing but the distance, dissimilarity. That's why that is completely internal validity. Dissimilarity. Intercluster and intracluster. Relative index is used to compare 2 different clustering or clusters. Often an external or internal is used for this function. Is sum of squared error or entropy. Winner is the entropy word. Thanks. Sometimes these are referred as criteria instead of this. Next, last one. These 2. Same. I have not had any other, only those. Right, you can close. This is regarding cluster analysis. This is very, very important topic. If you want to do project in clustering, you need to go through. If you want to do project in data mining, possibilities are association rule mining, classification and clustering. If you see the 100% community, 50% of the students will select for clustering. Remaining 50%, 30% may go for classification, 10 to 15% may go for association. In addition to these things, my sincere advice is, please visit Syed website, who is a scholar of Vipin Kumar. He has given the entire data mining map. Data mining can be applied 2 types. One is on historical data, real-time data. For what purpose? One is for prediction purpose, and second one is grouping purpose. Like that. Complete history, complete map he has given. Okay? Or you please share me your group ID so that I will share the important links to you. Right? Good luck.